All right, so we're on to lesson 2 on the trig unit. And again, I will just apologize. I have my lab with me, and sometimes he likes to shout the answers out of turn. So we're continuing on with trig ratios and essentially applying SOHCAHTOA into a circle. Since once you go on to 30-1, you're going to be dealing with a lot of these values in the circle and the unit circle, which we'll learn in a later lesson, and all of those relationships. So just remember, for Pythagoras, it's always a squared plus b squared equals c squared. So the two short legs squared and added give you your long legs squared and added. But since we're on a coordinate plane, we're going to use x, y, and r instead of a, b, and c. So because we have a point value here, and you can see from the triangle, we're going to always try to draw a triangle using the x-axis and then the vertical value, which would be your y-axis value. And then our radius is what joins the 2 points. So we'd have x squared plus y squared equals r squared. So it wants us to practice these given the following points, and we're going to use them in mixed radical form. So with this one, I have to put this point on the graph. So I'm at -5, +12, which is up here. And then putting my values in for that right angle triangle, we know I've gone -5 over and +12 up. So putting these together, I would have 12 squared plus -5 squared is going to give me my x, we'll just call it x squared. So I would have 144 plus 25 is equal to x squared, and that gets me 169 for my x squared. And then if you remember right, the last step of every Pythagoras problem is to square root. And so this one, square roots evenly, we don't have to worry about a mixed radical because the square root of 169 is 13. If I looked at the next one, I have a point here at -2 and -6. So I have a point value here down in this spot right here. So -2, -6. So that'd give me -2 there, -6 there. So again, I'd have to square and add those values to find my hypotenuse. So that would be 4 plus 36 is equal to x. And then we get 40 for this one. 40 does not square root evenly, so we are going to have to prime factor this. So 40 divided by 2 is 20, divided by 2 is 10, divided by 2 is 5, divided by 5 is 1. I can take out a group of 2, and I'm left with a 2 and a 5. So that would be 2 root 10 equals x. So that's how we can essentially use the Pythagoras theorem and what we've been learning about right angle triangles on a circle. If I go into the next one, if you remember from trig ratios from grade 10, and then, well, I guess now again in grade 11, we taught you SOHCAHTOA. So SOHCAHTOA, and that gave us our sides of our triangle based on the angle we had or were looking for. So sine ratio was your opposite side and your hypotenuse. Your cosine was your adjacent side and your hypotenuse. And your tangent was your opposite and your adjacent. What we're going to do with this now is, because we're dealing with it on an xy plane, we're going to switch it to x and y. So x, y, and r. So we know sine was opposite over hypotenuse. Cosine was adjacent over hypotenuse. And tangent is opposite over adjacent. So if we label this, there's my O side because I'm using that angle right here. There's my A side, and there's my H side. So sine law then, or sine, would be y over r. Cosine would be x over r, and tangent would be y over x. And you can memorize those. Again, you can find them by just remembering SOHCAHTOA and then relating that back to your triangle. So given the point here, I have a point 15 and 8. So that gives me a value of 15 for my x and 8 for my y. And they want me to do find r and then write my SOHCAHTOA out. So finding r we did on the previous page, it'd be 15 squared plus 8 squared is equal to my r squared. So 15 squared is 225. 8 squared is 64. And then 225 plus 64 is 289. So I have 289 here for r. And then again, my last step for that is to square root. And that one doesn't square root. I don't think. We'll just double check. 289 square rooted is 17. So this one does square root, so we don't have to worry about mixed radicals. So there, my r is 17. So now I can write my SOHCAHTOA. So sine is opposite over hypotenuse. So that would be 8 over 17. My cosine is adjacent over hypotenuse. That would be 15 over 17. And my tangent is opposite over adjacent. So that would be 8 over 15. 8 over 15. And that gives me all the answers for SOHCAHTOA on that. So then going along and showing our values, so trig ratios between 90 and 360. So it says we're going to use the point 1 and root 3, and we're going to show that the value is 60. So using 1 and root 3 would mean that this value is 1 and this value is root 3. So if I was trying to find an angle there, if you remember from grade 10, I would set up my SOHCAHTOA. I would use tan in this case because I have my opposite and my adjacent. And I'd have my opposite, which is root 3, and my adjacent, which is 1. And then to find my angle, I'd use second tan of root 3 over 1. So using my calculator, I would go out of my graph mode here, and I would go second tan root 3 divided by, I want that out of the root, divided by 1. And that gives me my angle. And make sure your mode is in degree mode. If it's not in degree mode, it's going to give you all of the wrong answers for grade 11. So doing that again, so second tan inverse of root 3 over 1, and we get 60 degrees. So that does equal to 60 degrees. So now they say they want us to find the value of r. So finding the value of r, I would have 1 squared plus root 3 squared, which is equal to 1 plus 3, which is 4, and then I'd have to square root 4. So r is equal to 2. So now it says complete the following. So x was 1, y was root 3, and r was 2, and we can fill out our values for that. So y over r is root 3 over 2. X over r is 1 over 2. And y over x is equal to root 3 over 1. Now they want us to look at it in a different quadrant. So the point QXY has the value, so it says it was reflected on the y-axis. So that would be, give you a value of -1 and positive root 3. The reference angle here is still 60 degrees, and the rotational angle would be 180 minus 60, which is 120 degrees. So filling these out, because I've rotated, it should still be, the only thing different here is that the x is now negative, so This is still root 3 over 2. This is going to become negative 1 over 2, and this is going to become root 3 over negative 1. And then looking at our next one, it's been flipped again, so this would now become negative 1, negative root 3. I still have a reference angle of 60. In this case, to find my standard angle, I'd have to add it to 80, so I have a standard angle of 240. And then filling out my SOHCAHTOA on the bottom, I have negative root 3 over 2. This would be negative 1 over 2, and this would be negative root 3 over negative 1, which works out to positive root 3 over 1. And then you can confirm those on your calculator. They do work out, and they are the right values. So going on to the next page here, we've now rotated it one more time. So we have 1 and negative root 3. Our reference angle is still 60 degrees, and that makes our rotational angle then 360 minus 60 degrees, which gives me a rotational angle of 300 degrees. So filling out our SOHCAHTOA for the last time here, we would have negative root 3 over 2. We would have 1 over 2, and then we'd have negative root 3 over 1. So then it says, looking at your observations here, what do you notice? And you'll notice that the trig ratios are exactly the same. The only thing that changes is whether the answer is positive or negative. So then determining the value here, it's going to depend on if your x or your y is positive. So it wants us to fill out the fraction and then say whether it's positive or negative. So what sine is y over r, cos is x over r, tan is y over x. So my first bin here, my sine would be positive, my radius is always positive, so that leaves me with positive. My cos, my x is negative, but my radius, which is always positive, so I have negative over positive, so that leaves me with negative. And then here I would have positive divided by a negative. That leaves me with a negative answer. And then for quadrant 1, we'll finish that off. So in quadrant 1, every value is positive. So I'd have positive over positive, which is positive, and positive over positive, which is positive. And then I get into quadrant 3, which is still the same, but in this case, x and y are both negative. So this would be negative over positive, which is negative. This would be negative over positive, which is negative. This would be negative over a negative, which is positive. And then my last quadrant, and I'll just write these here, so negative, negative. This is positive, positive. And this one is negative, positive. And this one is positive, negative. So in my last quadrant then, I would have a negative over a positive, which is negative. I would have a positive over a positive, which is positive. And I have a negative over a positive, which is negative. So you'll notice in this case that except for the very first quadrant, there's only ever going to be one value after that is positive. Everything else is negative. So apart from your very first quadrant, everything else, there's only one positive thing in each of those quadrants. And so putting that onto the next page, it says here, and they want us to go through and list which ones they're positive. So sine is positive in 1 and 2. Cosine was positive in 1 and 4. Tangent was positive in 1 and 3. Sine was negative in 3 and 4. Cosine was negative in 2 and 3. And tangent was negative in 2 and 4. So this comes about with what the cast rule is. So the cast rule is just a way to remember where it's positive. So cosine ratio was positive in quadrant 4, so that's the C quadrant. Then everything was positive in quadrant 1, that's A. Only sine was positive in quadrant 2, so that's S. And then only T was positive in quadrant 3, so that is t. So just looking at these diagrams, then we should be able to tell whether the answer is positive or negative just based on where it lands. So if I look at my first angle there, I'm in the fourth quadrant, but I'm in sine. So sine is not positive in the fourth quadrant, only cosine is. So that answer is negative. If I look at 227, 227 falls in the third quadrant. In the third quadrant, tan is positive, so that answer will be positive. If I look at 88, that is in my first quadrant. In my first quadrant, everything is positive, so that answer is positive. If I look at 235, 235 falls in my third quadrant. In my third quadrant, it's tangent that's positive, so that answer is negative. If I look at 308, 308 is in the fourth quadrant, and cosine is positive in the fourth quadrant, so that one will be positive. And then my last one here, tan is in the second quadrant. In the second quadrant, sine is positive, so tan here would be negative. So trig ratios of an angle in terms of the reference angle, we can figure out, we can rewrite the trig equation using positives and negatives and the reference angle to get our answer as opposed to writing it in the standard angle. So for example, for 260, 260 is right here. So there's 260. And 260 has a reference angle of 60 degrees here. Or sorry, 80 degrees. It's got a reference angle of 80 degrees there for the reference. So if you remember from a few previous slides, as long as they have the same reference angle, they have the same angle measurement. It just changes whether they're positive or negative. So if I look at this and I'm looking for 260, in this quadrant, in that third quadrant, cosine is negative. So I could say that negative of cos 80 is equal to cos of 260. Because I've taken my reference angle, but my reference angle is always going to give me a positive answer. And so I've just made the answer negative by throwing the negative out front. So we've got a little bit of practice with this, and then I've got some questions for you to practice. So they want us to write these with reference angles. So sine of 140 is that quadrant right there. That gives us a reference angle of 40 here. And then using cast, which I'll just put in this top corner here, so I only have to rewrite it once. In that quadrant, sine is positive, so sine of 40 would give us the same answer as sine of 140. If I look at my second one here, I have tan of 323, which is in that quadrant. That gives me a reference angle here of 37 degrees. And then because cosine is the one that's positive in that quadrant, I would have to write negative tan of 37 to get me the same answer as tan of 323. If I look at cosine of 165, that's in that quadrant. So I have a reference angle here of 15 degrees. So going through this, I would have, and then in that quadrant, sine is positive, so this is going to be a negative cos of 15 degrees, would give us the same answer as cos of 165. And then looking at this next one, I have tan of 287, which is down here in my third, 287 is in my fourth quadrant. So 287 is over here in my fourth quadrant. So my reference angle on that is 73 degrees. And in that quadrant, cosine is positive, so this would have to be a negative sine of 73 degrees to give us the same answer as 287. If I looked at cos 308, 308 is in my fourth quadrant, so my reference angle here is 52. And then cosine is positive in the fourth quadrant, so my cos of 52 should be the same answer as my cos of 308. And then my last one here, I have tan of 199, which is in that quadrant, which gives me a reference angle of 19 degrees. Tan is positive in that quadrant, so tan of 19 should give me the same answer as tan of 199. So that's just another way to write our angles, and it's just using our reference angles to state what they equal to. And they've given you this chart here to help you remember that. But for practice here, between writing your trig ratios and doing those positive negative angles, I want you to try these questions.